Hi everyone, I hope I've come back. I seem to disconnect from Loom, so apologies for that. I was in the process of trying to illustrate to you the relationship I think this one has. It's not a very obvious one, and this is the only way I can think of to adequately describe it to you. Okay, so what I've noticed is it doesn't matter whether it's the middle of the target or the outside of the target, and that's what really got me to start off with this question that didn't make any sense whatsoever until I realised that regardless of whether it's the middle or the outside, there's the same number of grey bits, black bits and white bits in each box. So each box has got one grey bit, which I've now coloured in red so that you can see it. It's got two black bits, which I've coloured in blue so that you can see them. And then it has 5 white bits. And those are the bits that I've coloured in green so that you can see them. A middle and an outside, and another 3 makes 5. So you could do the same to type B, to the set B ones, and if you did that you would find with set B that you've got 2 black segments, 3 grey segments and 3 white segments. So this is an example of one that is just mean. They do vary in difficulty, and I would say that in the time that you've got, this is probably a more difficult one. But it's one to remember when you get targets now in the future. If you get a little target and you're actually struggling to see the relationship, think about whether or not it's not actually the outers and the inners, but actually they don't make any difference. So let's allocate our shapes. I'll give you another 30 seconds and you can see, now that you know what the rule is, see if you can allocate the shapes. Stop. So the first one, we've got 2 3 3 set B. Next one 2 3 3 set B. The next one 2 2 4. That's not right, so that one must be neither. And then we've got 1 2 5, must be set A. And then that one doesn't fit, does it, because we've got too much grey for any of the boxes, so that's neither. Okay, that was a bit mean, that one, but I hope you enjoyed it. Let's move on to exercise number 7, clocks. And your 1 minute starts now. and stop. So I would start by writing my numbers just to make life slightly quicker for me. 2 and 30. Obviously you've got to take into account that the little hand is pointing at hours and the big hand is pointing at minutes when you're doing your numbers. So that would be 6 and 10. I'm just going to do 3 of them on each of the sets. 20 and 6 and 4 and 30 and 5. That's a mean one, isn't it? I think that's 24. Okay. And then I'm going to have a look at if there's anything that I can do. There's no obvious angle relationship. So that's the other thing to rule out, was whether any angles or anything like that that might be useful, but there isn't. This is one where either adding, subtracting, multiplying the numbers on the clock can be quite helpful. So if I multiply those numbers together, 12 times 5, 2 times 30, 6 times 10, that's enough. 6 times 20, that's going to be double, isn't it? So 4 30s and 5 times 24. Right, okay, so I haven't done all of them, but hopefully you can see that we've got to a solution here. As if I multiply the hands of the clock together, I'm going to get a number. So I'll give you another 30 seconds now you know the solution to see if you can allocate the shapes. Off you go. And stop. So we've got 3 times 5 is 15, neither. 3 times 45 is 135, is neither. 3 times 30 is 90, neither. Here we've got a set B, that's 120. Then we've got the last one, gosh, is massive. Is that 60 or is that 0 for the big one? It's either 0 or it's 540. Either way, it's either 9 times nothing or 9 times 60, which is 540. So it's neither either way. So the only one that we've got was the one that was going to be 10 times 12. Okay, which is the set B one. So on to practice exercise number 8, and your minute starts now. Smiley faces. And stop. Now, this is quite a sweet one. We've got little faces. When I look at the faces, what I notice straight away is that both set A and set B have a lot of features in common. So both set A and set B have got single brows and double brows. All of them have got eyes, nose and mouth. All of them have got a mixture of all of the different shapes, ovals, 2 nostrils, 1 big nose, a triangle for a nose. They've got smiles, they've got frowns. So it's not going to be any of the obvious things. It's going to have to be down to the number of items in each face. So it's going to be worth counting. So in set A, I've got 1, 2, 3, 4, 5, 6, 7. Let's just double check that that's consistent. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So let's check this one now. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's the answer. 30 seconds to allocate the rest of your objects, starting now. And stop. Okay, so just a nice straightforward counting up of the objects should put the first one into B, the second one into A, and then the rest of them A. Fantastic. That was, I think, an example of a more straightforward one, actually. I suppose it might be difficult if you'd have been sort of spending ages trying to think about, is it smiling, is it frowning, how many eyebrows does it have? You could have been ending up looking at them for a long time. So that's when sometimes seeing the fact it is a face is a distraction, and to bring it down to objects again. Okay. Oh, these two are going to be quite similar to each other, I think. They've both got the kind of first glance, I'm thinking, oh gosh, I'm going to have to do some counting here. So let's start with number 9, and your 1 minute starts now. Okay, that's your 1 minute. Now this one isn't what I thought it was going to be. I thought I was going to have to start counting the objects, but when I did, I couldn't find a pattern. So then I quickly counted sides, and I couldn't see the same number of sides. Instantly I could tell there couldn't possibly be the same number of sides either, because of the different numbers of triangles and squares with multiple sides in. I couldn't see any relationship with white and black, so I had to conclude that I wasn't counting anything because there wasn't anything to count. So I had to start thinking about the shapes themselves and the patterns that those shapes are making. I wonder if you got to that, but if I want to give you a hint now, I think the way to do this is to think about the patterns of the shapes. Look for if a particular shape out of all of the shapes in the box See if that is making a particular pattern. I'm going to give you another 30 seconds with the clue because I thought this one was quite tricky. So another 30 seconds with the clue. It's not to do with counting, it's to do with the patterns that the shapes are making. Okay, I wonder if in that extra time you got the answer. So what I could see is that the circles are in a straight line. Whereas in set B, the triangles are in a straight line. I think that's quite a mean one, to be honest. But once I'd eliminated the prospect of counting anything, it had to be something to do with the pattern that the shapes were making. This is one of those examples where you might not have got it, and you might have had to do that kind of look more from a distance at it, because it was at the point I did that I spotted that the circles were in a line. I didn't really spot it with the triangles. I had to conclude it with the triangles from thinking it's got to be mirrored, so which objects could be doing that, because it wasn't as clear to me as the triangles. I think it was possibly that cell that gave it away and made me think about whether or not all the circles were in a straight line. So if we have a look at allocating, now that you know the answer, I'm going to give you 30 seconds to allocate. And stop. Okay, this first one, I can draw two straight lines. I can draw that one and that one, so it's neither. In this one, I can draw two straight lines, so it's neither. In this one, I can only draw the one straight line, so that must be set A through circles. That one, I can only draw that one, which must be set A, and in this last one I can only draw one, and it's also set A. Okay, so having a look at the next one then, I'm hoping this one involves some kind of counting. I'm going to give you a minute to have a look at practice exercise number 10, starting now. And stop. Okay, so I'm relieved that this one does seem to require some counting, and the first thing that I noticed when I was looking at this one is that there is a big object in each of the squares, and those big objects are white if they are on set A, and they are black if they are in set B. So that was quite a nice, big, obvious one. And already I can see that shape 10.4 must be neither, because it's got two big objects. So it's always nice to be able to use something easy to get one chalked off the board straight away without needing to overly think about it. So the next thing I noticed about these objects is that there appears to be more circles in the square with the octagon in. I thought initially that it was the same number of sides. I thought it was 8, but when I counted them it was 7. So I was a little bit disappointed because I thought that was going to be a correlation. But I had still noticed that there does seem to be some relationship here, because I had 7 circles, 2, 2, 3, 2 and 4. So it appears to be that the number of black dots is the number of sides in the what I'll call the master object minus 1. So there should be 8 dots if it was the number of sides, but there's 7. Should be 3 dots, but there's 2. So it's the same number as the master object. And then when I tested that theory on the set B, I would be looking for a mirrored theory. So I'm thinking perhaps, is it sides plus 1? So if I look at the first square there, I've got a black circle and 2 squares. Well, the circle has 1 side, so 2. That does look like it's right. And that, again, looking through them, seems to be mirrored in all the others. So here I've got 2 with the 1, 4 with the 3, 5 with the 4, 4 with the 3, 2 with the 1, and then for my parallelogram I've got 5 for the 4 sides. So I've got sides minus 1 and sides plus 1. There seems to be something a little bit subtle. That I was looking at the redundant object to see if there was anything to do with that was important. Set A, the redundant object, does seem to be just a distractor because it doesn't match anything. But in set B, the redundant object is the same as the big object every single time. So set B has an extra important feature that we have to take into account for something to be in set B. So it's actually harder to get into set B because we've got this extra feature. So knowing the solution, you've got 30 seconds now to try and allocate your objects. And always remember, allocating the objects is the only thing that gets the marks. Coming up with any kind of elaborate pattern doesn't get you any marks at all. So make sure you are precise when you allocate your solution. Time starts now. And stop. So my first one then, it's got a hexagon with 5 black objects, which is correct, 6, and I've got 5 black objects, and it doesn't matter what the third thing is for set A, so that must be set A. Now the next one can only be part of set A because it's got a big white object, but it's got a 4-sided object with 5 black dots, so that can't be in either of them. Then the next one might appear in set B, but it can't do because it's got a circle in there instead of a parallelogram. So I don't even need to count anything to know that that doesn't fit. And then the very last one, I've got the big black object and the small clear object which matches it. I'm now just looking for 4 plus 1, which is 5, to say that that is in set B. Okay. Moving on, let's have a go at practice number 11. Okay, and your 1 minute starts now. and stop. Okay, so this is one where there's a lot of distraction in this particular one to deal with, because if you have a look at set A and set B, you can't count anything because there are similar numbers and similar numbers of shapes on both sides, there's similar numbers of sides, there's similar number of angles. So we're not counting anything, we're not rotating anything, we're not looking at any angles. We've got to look straight away to see what each set has in common with itself to start off with. And the only distinguishing feature that I can pick out is that they've all got a clear object in the top left hand corner, and the same is true in set B. So this object is what we call a key. This object is going to be the object which determines the solution in the set A situation and the set B situation. If you look at this object and the shape that it is, there are other objects in the set which are the same shape. Hang on a minute, do I mean that? Or do I mean that one? Do I mean that one? Does it matter that it's rotated? I think it does. I think that shape counts as something different. There we go. I think that. I think that counts. I think they both count. Right, so I think what the difference is that the colour of the object matters in its relationship with the first object. Okay, so I think it's most obvious in this cell here that if the key object, this one here, has another copy of itself 2 away, it will be grey. I need to take off my red to be able to see that. Take my red off now that I've worked out what I'm doing. If my key object has a copy of itself 2 spaces away, that copy will be grey. If it is 3 spaces away, that copy will be black. And that is the rule that works in the first one. 2 spaces away, the copy will be grey. 2 spaces away, the copy will be grey. 3 spaces away, the copy will be black. 2 spaces away, the copy will be grey. 1 space away, the copy will be grey. 2 spaces away, the copy will be black. Quite a tricky one. One of those where you might just, if you don't get it, you might have to guess on this one. I think it's one of the harder ones. You might not. It might have jumped out really obviously to you. Sometimes it does different things for different people. So, now that you've got the solution, I give you 30 seconds to allocate your shapes. Okay, and stop. So the first one, key shape, 1 away is grey, 2 away is black, set B. Key shape, 1 away we don't have, 2 away is black, set B. Next one, 1 away is black. That doesn't fit with either strategy. 2 away is black in the next one, so that is set B. And here we've got 1 away is both grey and black, so that can't possibly be either of them. Okay, so for me that was a much more tricky one. I wonder how you felt about that one. Well done if you did that more quickly than we did it together. So that was for me more tricky. Having a look at practice number 12. Let's see how you get on with this one. Your time starts now. And stop. Okay, so I wondered if you noticed that all of these shapes are in the same order in both set A and set B. So the order, if we start in the top left hand side of this one with the triangle, is a triangle, diamond, circle, heart, moon, square. It replicates in all of them. Triangle, diamond, circle, heart, moon, square. Triangle, diamond, circle, heart, moon, square. Triangle, diamond, circle, heart, moon, square. So I would straight away get rid of anything that doesn't follow that pattern in the bottom and get myself a quick, easy mark. It's not going to tell me the difference between set A and set B, but it is going to tell me if something is in neither. So I need to look quickly across them all and see if any of them don't follow that pattern. Triangle, diamond. So triangle, that first one goes triangle, circle. So that can't be either. Let me look at the next one. Triangle, diamond, heart, moon, square. Triangle, diamond, circle, heart, moon, square. Triangle, diamond, circle, heart, moon, square. Triangle, diamond, circle, heart, moon, square. They all follow it. I thought I might be able to eliminate more that way than I could. Right, the next thing to think about is patterns in the colours. Now, if you have a look at them, there doesn't seem to be any correlation with the numbers of whites, greys and blacks, because in both set A and set B I've got examples where I've got 2 whites, 2 greys, more than 1 white and no greys. So on both sides there doesn't seem to be a correlation for all the shapes. However, the top line sprung out at me a little bit and I noticed something that then seemed to actually tie in further down. This could have been just by chance, but I noticed that it can't be coincidence that the circle and the square have always got the same colour. So I then decided to have a look and see if that was also the case over on this side, and that's where I kind of fell down a little bit because they weren't. But there is a relationship where they are always different. So the triangle, let me see. Now hang on a minute, they are all the same, look. They are. That looks right. Yeah, I found it now. Okay. So that seems to be the pattern. So that being the pattern, I think I've got the circle and the square are always the same colour on set A, and the triangle and the heart are always the same colour on set B. Is there anything else that I've missed? I'm going to try now, I'm going to give us our 30 seconds, I'm going to try and allocate them and see if that allows me to make an allocation. So your 30 seconds starts now. And stop. Okay, so triangle, heart, same colour, set B. Next one must be, let's have a look. Triangle, heart are different, circle, square are the same, set A. Next one, triangle, heart are the same, so that must be set B. Then I've got, both. I don't think that happens anywhere, so that means I can't tell the difference between the two, so that must be neither. They mustn't fit in either, so neither B, A, B, neither. Okay, so let's have a look at practice 13. Some more kind of dartboard looking ones here, and your 1 minute starts now. And stop. Okay. Oh, I like this one. So, what I noticed first of all, it actually sprung out at me more with set B than it did with set A. So what I noticed is where the little dots in the middle are white, then the background is black. And where the dots in the middle are black, the background is white. So then I took to having a look at the set A, and I noticed that where the spots are black, the background is black, and where the spots are white, the background is white. So that's the opposite way around, as you would expect, it's mirroring. But I also have these nifty ones on this side where if it's black and white, we get a grey background. So now I understand the background, but I think to be able to allocate these completely, I think the numbers of dots, I need to think about the numbers of dots inside the target shape, and that I've got 1 if it's in top left, 2 if it's in the next quadrant round, if it's bottom right I've got 3, and bottom left I've got 4. And that's universal. It doesn't matter what colour they are, they have to go in that order. 1, 2, 3, 4. On set B, the same is true, except it's 1 segment further round. So 1 is here, 2 is here, 3 is here, and 4. In fact, this bottom right-hand one illustrates it perfectly, doesn't it? So that is the solution. Have a go at the shapes. Your time starts now.